Hello, I'm Mr. Camigo. I'm going to be y'all's engineering teacher for Principles of Applied Engineering. I know that I'm not going to see a lot of us till September 8th because we're doing the virtual start. That being said, a lot of the material we would be doing this first couple weeks would be CAD design. We're going to have to push that back. So what we're going to have you all start out with is looking through some of the other material, which is going to be some, I think there's like history of engineering, some stuff about engineering careers, emerging technology. So it's going to be some quizzes and some writings. And then I'm going to post a bunch of demos of building parts in, say, SolidWorks and LabVIEW. So we'll have you all watch demos so you get familiar with it, kind of watching what I'm doing in the demos. And then hopefully when we get there on September 8th and we start building the parts ourselves, the stuff you are watching me do in the demos, that hopefully translates over to where we're able to get going pretty well on this once we're all in the lab and using our CAD design program. So with this slideshow, I'm just going to give a little bit about just what this course is, and I'm going to set up some of the classroom expectations and policy stuff. And I know that we're virtual right now, but as we transition on September 8th back into the classroom, this is stuff that's going to apply. So about me, again, I'm Mr. Camigo. I got a bachelor's in physics, a bachelor's in math, and a master's in math. I've been teaching math since 2004, and I took over the engineering courses here in 2015, or some of the engineering courses. Mr. St. John teaches the Engineering 2 course, where we do SolidWorks certification. So we're going to start in with just some of the classroom environment stuff. So I'd like y'all to treat each other and myself with respect, follow student code of conduct. In the lab, work on what you're supposed to be doing. So some of our assignments are going to be on the computer where you're working in software, and I'd like it if you guys would be working on the actual project you're supposed to be working on and not tabbing around to other stuff. While we're doing lecture, let's keep phones put away. Let's treat the lab equipment with respect and care. And please turn your stuff in on time. So kind of continuing on, we're not going to bring food in the classroom, and especially with COVID-19 going around, we don't want people eating in the classrooms. Strong scents like cologne or perfume, don't apply those at the beginning before you get here at school. Don't put those on in my classroom. Need to keep classroom a scent-free zone. Again, take care when you're moving around that you don't break any of the computers. We're gonna have 3 restroom passes or 3 restroom uses per 9 weeks. So save that for when you actually need it. And when you do use the restroom, use the first floor. We don't want you wandering around the building. And don't leave class without pass. If you have to leave class, you make sure you get a pass. Okay, a couple things about COVID-19. While we're in class and on campus, you need to wear a mask that covers both nose and mouth, and we need to wear that at all times while we're in class here. So just a fabric mask covers your nose and your mouth. That is something we need to be doing. Again, no food in the classroom. So I don't want you pulling your mask off to eat snacks, that sort of thing in class, so keep food put away. Due to contact tracing, we're gonna, you need to sit, when we do get in class, there will be a seating chart. You need to sit where you're assigned, because if someone in the class gets sick, they need to know who was around them. And I'm gonna space that out as much as we can in with the seating chart. And also, I need y'all to minimize moving around the classroom. So I know sometimes if you're working on something and someone on the across of the classroom, you want to work together on something or go look at them. I want you guys to stay in your areas where you're assigned, so that we minimize people moving back and forth across the classroom. Course material. So we just need some sort of notebook or spiral for the class. We're going to have you all create, we'll do some diagrams in there. We'll do some sketches for prototypes in there that we'll then, later on, build fuller in CAD design. When we do the initial planning parts of projects, we're always going to start out on the notebook. And it's a good idea if you all build an e-portfolio to include those basic planning stages in your e-portfolio. So it can be a spiral. Ideally, if you get one of these little composition notebooks, those are really great. They have some of these that even have graph paper in them. But if you have just a regular old spiral, that's going to work for this class. Okay, cell phone. So during lecture time, keep the cell phone put away. If you have phone out when it's not supposed to be, I'll take it up, give it back to you at the end of class period. If I'm constantly having to take your phone up because you're not doing work, you're looking at your phone or whatever, I'll give you a referral, talk with your parents about it, and we'll escalate it from there. So just keep put away when you're supposed to keep it put away and work on what you're supposed to. Okay, computer use. So there's going to be time in this class that you're going to be working on assignments. One thing, when you're logged into these computers and this, the district monitors sometimes records what you're doing. So use good judgment. If you're logged into our network, it knows who you are, and whatever you're posting, you need to make sure you're doing the correct things on what you post. So use good judgment there. If you're posting bad stuff or looking at things that you're not supposed to, me or IT will find that out, and they'll take care of it accordingly. Again, computers are pretty new. A lot of classes use them. Let's keep them nice and be careful around them. I don't want to see you do things like ripping keys off keyboards or, yanking the mouse around or unplugging each other's stuff. Let's just try to keep this equipment as nice as it can be. All right, so engineering. We got the actual definition there. I'm just going to summarize it. Basically, science expands human knowledge through observing the natural world. And what engineering does is takes that knowledge base that science has expanded, and it takes that knowledge and it builds products that can help people in real life. So engineers take the knowledge and they build designs for products or processes that will help humans do neat things, basically. We're going to focus in this class, we're going to explore some careers in engineering. These are kind of the main branches of engineering. We got mechanical, electrical, chemical, biomedical, civil, environmental, computer. And there's other stuff, like I didn't include aerospace or marine. There's a bunch of different types of engineering. But these are some of the main branches that we'll focus on. But when we do some of the exploring careers, there will be, if you're interested in like aerospace or something like that, there'll be time for you to explore that type of career, certainly. So what do we focus on in this class? So a lot of this is going to be the engineering design process. That's what we use to go from, hey, here's a problem that affects a group of people, and follows that through to a prototype that solves the problem. We do CAD design. We're going to use SolidWorks. We have some stuff in the that we talk about, effects of engineering on culture, professional conduct, and we're going to get some initial learning how to code in Python and a couple other things. So we want to talk a bit about what are the math requirements. If you wanted to be an engineer and you're going to college, what math classes are we taking? College algebra is kind of equivalent to Algebra 2. So classes that are in green are most colleges require you to take. Every college's requirements are a little bit different, but if you wanted to be an engineer, most colleges would have you taking college algebra, pre-calc, calculus 1, calculus 2, calculus 3, differential equations, and linear algebra. Some colleges will have you go further than differential equations. This is sort of the calculus branch, and they'll have you take up to partial differential equations. Some of them also want you to take vector calculus. Probability and statistics, occasionally you'll have to take that. And if you're going to be computer engineering, sometimes they want you to take discrete mathematics. So if you want to be an engineer, this is sort of the math requirements that most colleges have. So stuff in green, most likely is going to be required. Yellow is stuff that they might also require you to do, and orange would be for computer engineering. If instead of saying, well, I don't want to be an engineer, I'd like to be an engineering technician or maybe a technologist, when I looked at those degree programs, most of them wanted you to take up to Calculus 2, And some other ones wanted you to take Cal 3, differential equations, linear algebra, and occasionally probability and statistics. So a little bit less math if you're going for a degree as a technician or a technologist. Again, this is, I'm saying probably required and sometimes required because not every college program is the same, and you can find, depending on what college it is, they may have you take more or less than what I have here. So a lot of our class is going to focus on the engineering design process. So we're going to use the Stanford engineering design process. It's empathize, define, ideate, prototype, and test. And basically what this is empathize is getting to know the group that you're going to design for. Because the better you know that group, the better your design is going to be tailored to them, and it will be a more successful solution. So empathize is basically where we look and say, okay, who are we designing this, this project for, and let's get to know what those people are like. In the define step, we kind of focus on what the actual issue is and try to frame the problem in terms of something called a point of view statement. And this is really going to it's going to really pin down who we're designing this for, what the issue is, and we'll have some like design elements in there that some conditions that need to be satisfied for the design to be considered successful. So the define step is where we really just develop this point of view statement, which kind of encompasses like this is what the problem is we're trying to solve. Ideate is the brainstorming step. So here we're not being critical of ideas. We're just trying to generate as many ideas as we can to solve this problem. And we want to get the obvious stuff out of our heads first, get that on paper first, and then start trying to push beyond the obvious stuff, because that's where the more interesting and the more innovative solutions usually come from, is once you get the obvious ideas on how to solve it down and start looking beyond it, that's kind of where we want to push ourselves in the ideate step. For prototype, this is where you say, okay, I've generated all my ideas. Let's start comparing them to each other and see what's successful, what's not. We don't need to develop a big prototype for every single idea. Some of them we maybe could just do a quick cardboard mock-up or maybe a quick sketch or something. And as we start developing these prototypes, we start testing them and comparing them against each other. And then depending on how the tests go, some of the prototypes will not like. Some of them will say, okay, this is good, but based on, what the users who are going to use it said, we need to go back and retool it and rework it a little bit. So that after you test, you kind of go back to the prototype phase and you refine it and you retest it and you kind of cycle back and through. But occasionally you'll hit a prototype where the prototype, you get to the testing and none of your prototypes work, and in that case you may have to jump back to the ideate or jump back to the define or jump back further than just the prototype step. If none of your prototypes worked, none of them were successful, then you need to kind of go back further in the design process and then continue on until you develop prototypes that do work. So we're going to be working with the engineering design process some in this class. Another thing, you all have Google Drive, so that's where we're going to be storing our files and our information. I'd like you to set up some sort of folder structure for the class. Make sure you're uploading files to Google Drive. Decide on, how am I going to group files? Like, should I have a, file for this class, my period 1 class, period 2A class, etc. Use subfolders to keep stuff organized, and keep personal, professional files separate. And sometimes it's also good to come up with like a naming method so that you're using a similar naming method for, maybe you have the date and then the file name or something like that. But it is a good idea to kind of think about how should I organize my stuff and come up with a nice method on how you're going to plan to organize your files for the year, because we're going to be generating quite a bit of different types of files. We'll have like, SolidWorks file, we'll have Python files, some docs, some slides, some spreadsheet stuff. So it's a good idea to kind of think about that ahead of time and start setting up a structure that you can just load your work into. ePortfolio. So I encourage y'all, start an e-portfolio for yourself. There's here's some examples of places you could build a portfolio through. I think these are it's like Wix, Folio HD, Weebly. There's probably some other ones out there. But this is basically a place where you will showcase projects that you've been working on. You want to consider what to put in there. Like if you have some bad work that you just slop something together to turn it in to get a grade, you probably don't want to include that in your portfolio. Only include your good work. You want to include all the steps of the design process. So this is from the initial planning, sketches, brainstorms, on up to prototyping and your final product. So you can include projects that you've done, education, any other neat work experience you have, maybe some courses you can take. This is all stuff that you might want to consider putting in there. And later on in the course, when we start talking about this, we'll look at some examples of what they should look like. But if you want to start, looking through probably free platforms to host a portfolio on, that might be a good thing to get started with. So software we're going to be using, software and hardware we're going to use SolidWorks. This is going to be our CAD design program. We're going to use LabVIEW. This is a data acquisition program. However, due to COVID-19, we can't use shared hands-on material, which basically means a lot of the breadboard electronic stuff, where we're building with common components, and the data acquisition stuff is going to be off the table till they give us the all clear for that. Raspberry Pis and Arduino are kind of the same thing. These get into breadboard circuitry stuff, shared materials, and we're not allowed to do that yet. But these are, I'll probably post some little demo projects for these. And okay. Well, I'll be posting probably some demos a little further in the course of like what a Raspberry Pi project or an Arduino project, so y'all can see that. We're going to be using Python, and hopefully is on your Chromebooks. And when we do these Python problems, we'll just learn how to code with that, because that's going to be something that's good to know in your engineering. So I think that's a kind of an overview of just kind of a bit about myself, a bit about classroom environment when we do get into class, a bit about what some of the material is, what some of the math requirements are for engineering, and we'll stop there.